Great. So before we start, I'm using light mode. So please, everybody, close your eyes for a second. Then we will switch the slides, and then open your eyes slowly, right? I don't want to hurt your eyes, so please close them now, and I'll give you a few seconds to open them. All right, you can open your eyes slowly. Maybe it's not that bad as I anticipated. I asked for a light theme start slide, but they didn't provide any, so yeah, here we go. Welcome to my talk about fingerprinting the fingerprinters and analysis of fingerprinting scripts and their actors on the internet. So who am I and why am I here talking about the topic? Well, maybe a few of you remember me from code.talks 2018 when I talked about bug bounty programs and how to coordinate vulnerability disclosure for companies and researchers. Since then, I've been working on my master thesis, finished it, on the topic of browser fingerprinting, and that is the reason why I feel a little bit confident to talk about the topic. So after that, I'm now a PhD candidate at the TU in Berlin, mainly in IT security, doing things, and as well, playing CTFs, still doing bug hunting from time to time, and also doing IT security work as a side job. So if you look me up on the internet, Google for Gehackselt, and you will find me. So let's get into the nice stuff. What is on our agenda? So I will introduce browser fingerprinting to you, what is it used for, how does it work. Then I will talk about how we can detect and analyze fingerprinting on the internet. And in the end, we'll talk about what actors or scripts are there, what they do, why they might do it. And in the end, we talk about what can we do about it. Is there anything we can do about it? We will see. So I believe many of you might have received such emails. You log into one service, and then you get an email. You have to type in this code to continue with your login flow. And you might have wondered, why did that happen? You might see the hint. You logged in from a different location, from a different device or a different browser. And you see things like the IP address, your operating system, your browser version, and of course the code you have to enter. So why is that, and what is happening in the background? Well, of course, you could detect a different login from a different location based on the IP address, but IP addresses change often, at least in Germany, I believe, every few days or so. So you don't want to bother the user every time he or she logs in. And geolocation isn't always perfect. And of course, the user agent, so the system, the browser version that is used, will change with browser updates, will change with system changes. So it's also not a pretty reliable way to detect a different login. So what else could be used or could be done to detect a different login? Oh, I see I'm a bit below the slides. Browser fingerprinting might be a technique used for that. So what is browser fingerprinting? It is a way to re-identify browsers or devices based on the different properties. What properties could we use for that? For example, the fonts that are accessible by the browser, installed plugins, different browser quirks. That means how are pages rendered, how is CSS processed, how is JavaScript executed, all the different things that you as developers might know or have pain with when developing websites could be used for browser fingerprinting as well. And then we have HTTP headers, of course, language setting, and any other setting that your browser might have. Then more information could be obtained from your device. For example, the amount of installed RAM, your CPU, GPU processing quirks, maybe even the battery status. But as far as I know, the battery API wasn't really implemented due to privacy or security concerns. But still, there's the screen resolution, your audio APIs, your sound card, everything that processes some information will do so a little bit different on different systems, which provides information for fingerprinting. So for that, if you don't believe me that this works, let's do a short live demo and go to miunique.org to see how unique my system is. So this is a research website by some fellow researchers who try to track or keep up with the state-of-the-art fingerprinting techniques. So if you go on that website and click on My Fingerprint, then it will work on your browser, and you will see, well, are you unique? Yes. So my system is being unique inside the data set of around 800,000 fingerprints that were collected. So what makes me unique? Let's see. So apparently, my user agent is already pretty unique. Nobody, or not many other browsers that use that site have that long user agent with that information in it. So that makes me already unique, okay? What else do we have? Some headers, apparently. And then the juicy parts are these things here that can be accessed with JavaScript. So Canvas is one pretty good way to identify browsers, because as I said, there are some differences in your graphics chip. So for us humans, this text here might look the same for everyone, right? Even if you're on different systems, it will be green text and blue text. But in reality, if we compare the output of this canvas, it might differ in slight ways on different systems, because due to differences in the graphics chips that are processing that canvas. So this is a really good measure for making browser fingerprinting work. And as you can see, it makes me really unique. And of course, the fonts, some navigation properties. There are even some properties that are not that unique. I mean, yeah, I don't know. Java-enabled false pretty much applies to a lot of people, I guess, because no one's using applets anymore, I believe. But yeah, you can scroll down further and see WebGL, same story as above, makes nice polygons, but still makes me pretty fingerprintable. Audio formats as well. Oh, look, media devices. I'm pretty much unique, OK. And so on. So yeah, feel free to check that website and how unique you are on your mobile phone, on your desktop device, on your laptop, but not now, after my talk. So yeah, now we know that browser fingerprinting works. We can uniquely identify a system, a browser, maybe even a user. But yeah, why should we do that? And there's a dual-use dilemma. On one hand, it might improve security, but on the other hand, it might impact privacy. So what benefits for security do we have from browser fingerprinting? Well, we could mitigate unauthorized access, as we've seen in the example. When someone logs in to a pretty high-security website, you could ask them to verify again through other channels, think of two-factor, when you detect a different browser trying to log in. Then, of course, we have malicious activity. Think of bots, malicious traffic, web attacks, etc. So all these things, yeah, think of captchas, could be also used yeah, by browser fingerprinting. So you detect, OK, this system or this device is doing some nasty stuff. You can just block it based on that fingerprint. And maybe some of you know from the gaming community that modern anti-cheat systems are blocking systems or banning people based on their hardware configuration and fingerprint. So this could be the same. So what potential actors do we see in that space? Well, I would believe financial institutions and e-commerce, because they would like to prevent fraud or any financial loss. So yeah, maybe if we can prevent someone logging into your bank account or to your shopping account and ordering stuff and all that things. So if we can present that, browser fingerprinting is good. And of course, high security sites might benefit from that as well. On the other hand, we have impact on privacy. And I do not mean that in a positive way, because browser fingerprinting also allows to track users without cookies. We have all the cookie laws and cookie pop-ups, and at least in my circles, everyone rejecting the cookie. So attack people might have a bad time trying to track me or build a marketing profile or whatever. So they could now use browser fingerprinting to identify me across multiple sites, even across multiple different browsers. So if I start Firefox instead of Opera, I will have a pretty similar fingerprint because just one or maybe a few more properties changed, but not as much about my system. I won't change the RAM, I won't change the CPU or GPU every morning I wake up. So even across incognito tabs, I'm pretty much re-identifiable. And during the research that I did, everything related to fingerprinting that I observed was happening without any consent. So the scripts, the headless browsers that I ran, all did not accept any cookies, any privacy pop-ups, anything. And still, we had a lot of fingerprinting happening in the background. So for me as a user, it is hard to block or even circumvent or prevent being fingerprinted. So what potential actors might be interested in using that technology? Well, of course, ad tech, because they want to show you the best ads for you, and they need some way to track you and build a profile, etc. Of course, this might also apply to e-commerce, because, yeah, well, we know they also want to sell you stuff, and many other sites, right? So I, as a user, I do not really know what purpose the browser fingerprinting that the website might employ serves. So I do not know, do they do it for security purposes? Do they do it for, well, marketing or anti-privacy purposes? Or maybe even for both? I can't say that. And yeah, even I might not even notice it. So, well, I'm left in the dark. They just do their thing, and my privacy is gone. So let's talk about how this usually works. So please follow this green dot, right? Everyone probably knows in here how browsers work, how the basic internet works. So first, of course, if we would like to open the website example.com, we send a request this way from our browser to the server. Then we get a response with some document containing some script, which in this example is tracker.com track.js. This is then being processed in our browser, and the browser sends a request to tracker.com to fetch this track.js file. And now the browser already includes our user agent, even a do not track header, which is ironically enough even used for passive fingerprinting. So if you don't set it, you will be tracked. If you set it, you might be tracked as well. So yeah, the tracker then responds with this tracking script containing JavaScript to read out all our browser properties and do some fingerprinting stuff. They might even set a cookie, and then this is again processed by our browser, executed, the fingerprint is calculated, and in the end, all those scripts send either the fingerprint, like this random identifier, or all the information that they gathered back to the server. Yeah, so we can differentiate in active fingerprinting, which is, yeah, we execute a script to get all the properties, and passive fingerprinting, which is, yeah, we just look at what was passively sent, like HTTP headers. And in the end, tracker.com is able to calculate a hash or use the properties that they obtained to fingerprint us, to re-identify us. And if both entities, tracker.com and example.com, are the same, because you host your tracking scripts yourself, you could even correlate that to the user ID, to the user session, and then build a better profile or track them or maybe improve their security. So this is effective. It's being done in the wild, as we will see in the next slides. And yeah. So how did we measure that? For that, there are two tools that we have developed. One is the FP-Net Fingerprinting Networking Scanner, and the FPMON, which stands for Fingerprinting Monitoring. The FPMON is a Chrome extension that can be freely downloaded, that you will see on the right-hand side. So what does it do? It analyzes the website that your browser is on for all the different fingerprinting activity. So we have about 115 properties that we monitor, be it JavaScript properties or JavaScript function, and we map them to about 40 so-called fingerprinting features. On all the features, you will see on the right-hand side. So we split them in sensitive features and aggressive features, where aggressive features are believed to provide more entropy, more information for a better fingerprint, and sensitive features might play into a fingerprint, might provide some information, but might also be just of benign use. For example, yeah, I believe screen size is somewhere on this list, or yeah, screen window. So some JavaScript layouting might use screen window to readjust some layout stuff. So this is not really fingerprinting. But as we've seen, the window size could also be used for fingerprinting. So it's a bit hard to differentiate between those things. In the end, down here, you will see all these scripts and the amount of feature groups that they have accessed. So we can see there are some scripts that only access quite a few features, and then we have one script from @score.com that accesses 38 out of those 40 features, where we believe, there's something fishy going on. Why would they need so much information about me? And in order to scan for that, we developed this fancy tool. So since we are a developing conference, I wanted to include that. So we have a instrumentation Python script that will run n different Chrome-based, Selenium-based headless browsers with this extension loaded on different domains, and then it collects the information, sends them back to our monitoring system, and then we do some post-processing on that. All right, and again, I know that I said this will be code independent, but yeah, I couldn't resist to put some lines of code into my presentation. So yes, here are the different properties that we monitor, and then we have here some functions that will override the properties with some wrappers. So we can actually monitor the access. So if an ordinary script will call, I don't know, navigator.language, we will see that in this function, and then we know, okay, we can throw an artificial exception, run through the stack trace, and then find out which file actually calls that function, which is pretty neat. In the end, we collect all this information. And since the Chrome extension API allows us to execute our extension before the actual page load, we can override all the properties and JavaScript function before anything happens in the website, which helps a lot with our approach. So in the second step, we have collected all the information on the different scripts, so to say their behavior. So we can see tracker.com FPGS first accessed the navigator user agent property, then later on, down here, accessed the get image data, which we attribute to canvas operations. Then it accessed or executed or called draw arrays, fill tags, which we attribute to some other feature groups. And then we see example.com main.js, which just accessed screen window, which is one feature group. So using that information for every function call of every script that is being loaded on the website that we browse to, we can later on compute the so-called script signatures, which is all the feature groups in their order of being called concatenated together. So we can see, for example.com main.js is just screen window, which provides us a script score of 2. Oh, actually, there's a mistake. This is only 1, not 2, because we take the unique amount of feature groups. So this should be, where's my pointer? This should be 1, not 2. I'm sorry for that. And then for the more interesting script, tracker.com FPGS, we have 1, 2, 3, 4 different feature groups that are being accessed. So this script score is 4. And if we do that for all the scripts that we had, we can derive some activity classes from that. So we say for scripts that have a score lower than 3, the script is likely benign. It's not doing any fingerprinting, might not even get enough information from less or 2 categories, feature groups. So we ignore those scripts and say, yeah, they are not fingerprinting. Then we have scripts with 3 to 6 different feature groups, where we say, well, 6 feature groups might be enough for a weak fingerprint. So this script could exhibit some limited fingerprinting activity, but still, the scripts that we are the most interested in are these with a score greater than 6, because yeah, that should be enough information at some point to do some fingerprinting. So that's what we did in the next step. We looked at how active these scripts are. So only, we will look at those 9% high activity scripts on the next slide. So for now, let's have a look how all the accesses distribute. So you can see the low activity scripts are those with the green bars. So we can see they access the user agent, maybe storage, maybe screen window, and then it slowly fades away. So yeah, benign scripts likely. Okay, we can use the user agent or screen window to do some layouting maybe. And then we have medium activity scripts. You can see they in total access more feature groups. So we have content language, platform, list of plugins, maybe the vendor. But the very interesting scripts that we will look at are high accuracy. And you can see all the red bars are from those scripts accessing device memory, media devices, CPU class, WebDriver, and all the different properties that we monitored. And the distribution is about 60% low, 30% medium, 9% high of all the scripts that we've seen. So what do we do now? OK, there are some scripts with more activity. There are some scripts with less activity. Let's try to find out more. Who is behind a script? Who are operating all the fingerprinting scripts? So for that, we tried to group them into so-called networks. So how did we do that? We used the script signatures. So you remember the screen window, screen window, screen window feature groups that we concatenated as strings. We used these behavior strings and mapped them together, tried to find overlapping behavior, and then we grouped all the overlapping behavioring scripts together. And yeah, this table shows what we had in the end. So in the upper row, we see that there is a script from doubleclick.net, and all the 371 files that we have identified follow all the same name, like pub adds and then some random ID. The signature length, so the amount of identical behavior inside this script signature, is 30 identical calls, and they cover about 1,300 websites like blackdoctor.org, ebay.com, and any other. But they only have a score of 8. So only 8 feature groups are being accessed. And now, well, our assumption or way of thinking was, we have larger networks with a lower score, and then we have smaller networks with a higher score. So maybe one could be for tracking, maybe the other could be for security, because for security, you really want to make sure that the browser is legit and is able or allowed to access that site. And for tracking, you might just want some more information to complement your cookie-based or other approaches of re-identifying a user. So in this row, you can see that there is maxmind.com with a script called device.js that has 269 consecutive identical function calls to the feature groups, and it covers about 5 pages from the Alexa top 10,000 pages that we scanned, and it has a score of 36, which is pretty high. So yeah, what do we do with that? Well, we can also even group them further, and for every network that I identified of those 350, I went through them and tried to categorize them. So in the end, I ended up with that table. So we see the largest actor that covers the most pages is Google DoubleClick. So they have about 19 different networks that cover about 1,580 pages with a score of up to 10. Then we have Google AdSense with a much smaller number of about 500 websites and 11 networks. Here that's Metrica with 50 networks and 370 pages in Akamai. In the end, we have Fingerprint.js. This is a open source script that could be used for fingerprinting. You can just look it up on GitHub, and there's even a paid version, pro version of that. And we found that script on about 133 websites, and it has a score of 20. So again, some do a lot of fingerprinting, some do less fingerprinting. The funny thing is, according to the Google AdSense or double-click policies, you are not allowed to include any fingerprinting or tracking code into your ads or anything. But apparently, they still access some properties. So let's have a look at the top 5 actors covering at least 5 pages ranked by their score. So as you've seen before, we have MaxMind at the top. They had only one network, one file, so every website that we scanned had the same file included, which accessed 36 out of those 40 properties. And we found that file on 5 different websites. And then we have Oracle Moat, which we categorized, or was categorized into web advertisements, with also a pretty high score, 34 feature groups and 114 websites. And we have Akamai again. Is anyone working for Akamai? Please raise your hand. All right. Yeah, and some others. And you will find a list with all the actors in my master thesis, but it's so long I wouldn't be able to include it here. So let's have a closer look at what all the companies offer that we've just seen. So there's device tracking, capture more data and capture more fraud by MaxMind that we've seen with a pretty high score. So apparently they try to prevent fraud, and for that they probably use some kind of browser fingerprinting. The interesting aspect is that some companies openly state that they use some kind of device information and others do not. So yeah, we don't really know, are they really doing it? Is it just a byproduct of some other thing? But still, pretty much any actor that we identified is anywhere from web analytics to, again, spam protection, fraud protection, bot protection, more online fraud, even age capture, which says it's protecting users' privacy, had a pretty high score of about 20. So yeah, maybe a short disclaimer at that point. I did my master thesis in 2020, so those screenshots are like from yesterday, but still like the data that we have might be a bit older, so maybe some things have changed. Maybe they do less fingerprinting now, maybe even more. I didn't have the time to rerun the scan and provide you with more up-to-date data. I'm sorry for that. But still, we can see we have those two different aspects: security, prevent fraud, prevent bot accesses, and then we have analytics and measurement, grow your market, blah, 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 blah. All these things, advanced protection for your ad margins. So those things are being used by companies, and they employ browser fingerprinting to achieve their goals. So what can we do about it? So now a question to the audience, just a little check if you're already asleep. Who of you has not heard about browser fingerprinting before? Please raise your hand. 1, 2, 3, 4, 5, 6. All right, that is good. Who of you has noticed being browser fingerprinted while browsing? That's pretty, I don't know, 20, 30% maybe? Great, I will ask you in the Q&A how you noticed that. Because before I started with that, I knew that browser fingerprinting might be a thing, but I never noticed it, and I believed, well, if I'm not opening the network console and looking for outgoing data of my browser or the properties, I wouldn't even notice this. My grandpa for sure didn't notice it. So now the question, do we need more regulation? For example, like browser fingerprinting pop-ups that we have for cookies. I would say yes from a privacy standpoint, but from the user standpoint, UI standpoint, I will definitely say no, because I do not want to click more reject buttons. It's already enough. So what else is there that we could do against it? Yeah, some people might say just disable JavaScript. OK. True. I mean, it's a valid approach. But still, maybe not the best. We will see in the next slide. Then install some privacy plugins. All right. What plugins should we install? Then maybe we could try to block or detect fingerprinting scripts. How do we do it? And then in the end, we have some approaches that are randomizing properties and homogeneous properties. So look at that. So I had the same question. Maybe I can just disable JavaScript and live without browser fingerprinting, right? Would be easy, would be nice. But still, a scan that I did shows that about 87% of the Alexa top 10K sites use at least one on-event handler. So if I would disable JavaScript, all these handlers would not trigger, and the websites would not behave or work as they are intended by their developers. So, I mean, the reality is that if you try to disable JavaScript and browse the internet, it just doesn't work, at least for modern websites. And almost all websites try to be modern. So yeah, it's maybe not the most suitable way to deal with that for most users, maybe for some hardcore privacy people, but not for the average internet user. So maybe you can install some privacy plugins. So this is something my colleague looked at in his master thesis. So he compared the base score of Chrome with our extension to AdBlock, DuckDuckGo, and Privacy Badger. And it turns out that for some websites, the tracking score reduced. For example, on metacafe.com, the score went down from 95% to 20% with Privacy Badger, but not with AdBlock or not with DuckDuckGo. And for other sites, there was no change at all. For example, for Coinbase.com, it's all 85%. So yeah, maybe why is that? I mean, most privacy plugins work on a denialist basis. So there are people contributing URLs where fingerprinting or in general tracking ad scripts are located, and those are then blocked. So that might work. Maybe Privacy Badger has the best list and blocks most of those scripts that accidentally also do fingerprinting, but certainly not all. And why I'm saying this is on the next slide, because according to the things that I saw, some scripts or actors try to implement some kind of evasion tactic. So what does it mean? I scanned all the websites twice and then compared what script files changed or how their behavior changed. So we can see that of those roughly 10,000 URLs where the URL has changed, about 90% of the changes came from just randomized file names like this. Then we have about 12 domain changes, like one tracking script or one script that we observed being on this domain and then changing to this random domain, which looks pretty weird to me. I mean, OK, you can do that. Why not? And then we have about 800 file name and domain changes. So where both, for example, the top-level domain changed and the file name changed. Of course, this doesn't necessarily have to be some kind of evasion, because maybe they just redeployed their website and the post-processing pipeline recompressed, renamed some files, and this was then uploaded. And of course, this will change. But why would a redeployment change the domain to some random other string? Maybe your company does it. If you do so, raise your hand. Would be great to see. All right. Yeah. But still, there were also behavioral changes. So for about 7,000 URLs, which stayed the same, we compared the script signature, so their behavior. And we see, all right, for 86% of the scripts, the script signature stays the same, so it's the exact same behavior and execution flow, which is good. And then we have 92% of the remaining 40% that still have identical scores. So the same amount of feature groups is accessed, but it has a different script signature. So somehow the script changed, which would tell us, well, the behavior changed. Maybe they're trying to randomize their access patterns to those properties to not flag as many things. So yeah, it's not easy to detect or block fingerprinting script, I would say. One thing that I had in mind was to try and develop some kind of behavioral-based privacy extension that would analyze the function calls of these scripts, and if we detect some overlapping signature with already known bad scripts, then we could block the execution flow or maybe prevent even the data being sent back to the server. So as we are many developers here, is anyone up for this? Raise your hand. All right, maybe talk to me after the talk. Randomized properties. So this is the idea, well, maybe the time zone or the time functions could add some jitter, or the WebGL canvas could add some randomization to the rendering things that we still see, like the red and blue text, but it's still a little bit different in every call, which will break some fingerprinting scripts. But it also might break legit websites and functionalities. Think of a browser game, which also uses canvas or WebGL calls. If we do too much randomness, it might break, and then people are unhappy. So there's a thin line to walk between adding too much randomness and adding not enough randomness, and it all depends on the different properties. But I learned that Firefox has a privacy setting, resist fingerprinting, which try to go that approach. So they try to disguise some of their properties and even disable some other features. So you can try to enable that and browse your internet. Maybe you will fingerprint it less or less efficient. But still, there's another way, homogeneous properties. So the idea behind that is to make all browsers appear the same. Like if everyone has the same browser, we can all share the same fingerprint, but then all the identifying and tracking and security purposes are out of the window because, yeah, you can't differentiate between different systems anymore. And this only works if a lot of browsers or users do it, and I believe this will be the greatest challenge to get all people in all browsers to cooperate on that. So yeah, probably not the best approach. But a prominent example of that is a Tor browser, because you all know if you have started it once that it starts in a small window. So the screen size for a lot of people is the same. It has some features disabled. It sets the same user agent for every instance. And Apple Safari on Mac has a setting which tries to go this way as well. So if you enable that, it will apparently, according to them, your browser, your Safari will look like every other Mac. I'm not sure if that works. I do not have a Mac, but maybe you can tell me. So what can we do in the end, right? Of course, more research could be done. Browser fingerprinting is not a new topic. It has been around in academia and in general for quite a long while. But still, I feel like not enough people know about it or protect against it. So yeah, we should definitely educate people about it. Tell your grandma and your other family members. Then you as developers, you are sometimes responsible for choosing services, for choosing products, or even companies that provide fraud prevention, that provide security services, or other things. So maybe think twice if you really need that, if you really need their approach of browser fingerprinting, maybe read the terms if they are selling this information, those profiles, to some other people. So yeah, it's your task, or maybe part of your responsibility, or my wish for you, that you take care of that. And in the end, for me, for my privacy, for my good feeling, if we could think of more anti-fingerprinting measures and do some research on them, that would be great. If you have any ideas, hit me up during the conference or send me an email in the end. So yeah, I think we are pretty good on time and have plenty for Q&A. So yeah, thanks for listening, and yeah, now you can talk.